Hi, welcome to the Chico Math Lab Fun Probability Problems Solving Session. So today I'm going to prove the Bonferroni inequality, and I'm going to use the induction methods to prove this inequalities here. All right. Okay, so let's go ahead start it. Okay. Okay, so first let me write out the Bonferroni inequalities here. So basically, this is what we try to prove here is the probability if we have the E1, E2 to En and be the n events in the simple space. All right, so the general form, it will be I from 1 to n. Then you intersect all these events here, EI here. Then the Bonferroni inequality will tell you this one will be greater than or equal to, you add each probability for each events. So this will be P the EI and then minus and minus 1. Like I mentioned a while ago, I'm going to use the induction methods to prove it. Okay, so now the first step in the induction method, I'm going to show when the n equal to 2, this is true. Okay, so when n equal to 2 here, so basically I need to prove the probability E1 intersect E2 is going to be greater than equal to probability E1 plus probability E2 minus, so n equal to 2, 2 minus 1 is 1, minus 1. Okay, so I need to show this. Okay, so the way I show it, I will say, okay, so the probability E1 union E2, by the additional rule, I know this will be the E1 plus the probability the E2, then minus the probability of the E1 intersect the E2. And because the probability the E1 union E2, I know the whole thing has to be, the greater than or equal to, so this one is here going to be greater than or equal to 0 and less than or equal to 1, right? So I will put it here is greater than 0. So, but this one has to be less than equal to 1 because from the probability axiom, we know the probability cannot greater than 1. Okay, so that means this term going to be less than 1. Now, okay, so we know that means if you move the P to E1, E2, so this will be probability of the E1 intersect E2 going to be greater than, so you move the probability E1 intersect E2 to the right hand side of this inequality will be greater than P the E1 plus P the E2 minus 1. So we proved, so when n equal to 2 is true. Okay, so that's why I proved here. So from this ones here is when the n equal to 2 is true. Okay, so then the second step by inductions will be, so now we assume, okay, so when n equal to k minus 1, it's true also. Okay, so we assume that k minus 1 is true. Okay, so how do I do that? So that means the probability I intersect I from 1 to k minus 1. All right, so the k minus 1, okay, and the EI, that means is the probability E1 intersect E2 intersect all the way to E the k minus 1, correct? And based on this one, so it's going to be greater than or equal to probability E1 plus probability E2 plus the probability all the way to the ek minus 1, and the minus, now n is equal to k minus 1, so it's equal to k minus 2. Okay, so now we assume n equal to k minus 1 is true. So now the step number 3 is here. Then we need to show n equal to k is true. Okay, so if n equal to k, that means the probability E1 intersect E2 intersect, all the way to E, the k minus 1 intersect EK. That's right. Okay, so now in here, okay, so for these terms here, right? So for these terms, E1, E2 intersect the EK, intersect the EKs here. So I know because n equal to here, if you take a look here, because when n equal to 2 is true, so I can see that the E1 intersect E2 intersect EK is as one unit. So I know from my when n equal to 2 is true, so I can plug in to what I just proved, right? So this will be is greater than E1 intersect E2 intersect all the way to E, the k minus 1, then plus P, the EK, right? Minus 1 here. Okay, and now for this ones here, P, the E intersect, E1 intersect E2 intersect E, the k minus 1, we just assume this is truth here, right? So we know this ones here will be greater than equal to probability the E1 plus probability E2, then all the way to probability E to the k minus 1, then probability E, the k, I'm sorry here. Okay, so this one's minus, I think I better write this way, minus k minus 2, right? Then plus PEK minus 1. So what I basically just, this is my pink one, I just use this relation. So that's why I color code here. Okay, so now if you combine the minus, so take a look here. So this is the minus k plus 2 minus 1. So it's a minus k plus 1. So you can write this is a minus k minus 1. Right? Okay, so now I combined, so I can rewrite this equation to be, so the inequality still is truth, right? So this will be P, the E1 plus P, the E2, then plus P, the E, k minus 1 plus P, E, k minus what? K minus 1 here. All right. So now, because n equal to k, so now we know this is true. Okay. So this is true. So that's how we proved it, because now in here you can say, okay, so now because n equal to k is true, so when the k equal to n, then I know the probability of the I from 1 to n, ei, okay, so will be greater than, or equal to the summation I from 1 to n, p, the ei, then minus n minus 1, right? Because from here, okay, so let me see, okay, from here, right? So because, because now I can let k be equal to any numbers here, right? So that's why this one will be, so we proved it, okay? So this is finished. right? So we say this is proved. All right. So this is I find that this is very interesting and the proof and very it's not too hard. It's kind of straightforward. I hope you enjoyed this proof. All right. So now nice to talk to you and looking forward to work with you for our next fun probability problem. Have a good day. Okay. Bye.